In this video, we're going to talk about atomic mass. Now, Dalton's atomic theory, he thought all atoms of a given element have the same mass, which is incorrect. They have the same number of protons, but they can most certainly have different masses. And so we have this idea of atomic mass, or standard atomic weight, which is really a number that just tells us what the average mass of an element is. And you will find this in your periodic table under the element symbol. So for example, here's chlorine. Chlorine has 17 protons, and on average, a chlorine atom weighs 35.45 atomic mass units, or daltons. And this weight is calculated by looking at the natural abundance of each isotope and doing a calculation. So let's take a look at the formula for finding out atomic mass. And so we calculate atomic mass using the following equation. Atomic mass equals this sigma means sum. So it's the sum of n. N means how many isotopes we have. So do this operation for the number of isotopes we have. So we sum the fraction of isotope number 1, or n, times the mass of isotope number 1, or n. So for example, atomic mass equals fraction of isotope 1 times mass of isotope 1 plus the fraction of isotope 2 times the mass of isotope 2 plus the fraction of isotope 3 times the mass of isotope 3, and so on and so forth until you've covered all the isotopes of that specific element. So let's actually do an example calculation. Chlorine consists of 75.77% of chlorium-35, which has an atomic mass unit of 34.97. and 24.23% of chlorium-37, which has an atomic mass unit of 36.97. I want you to try and pause the video and see if you can figure out what is the atomic mass of the chlorine. And I'll see you when you have attempted that. Alright, so let's take a look at how to solve this. First, we want to take our percentages and we want to convert those to decimals. So we take each percentage and we divide by 100 to get 0.7577 and 0.2423. Next, multiply our converted percentages abundance by the atomic mass that it goes with. So we take 0.7577 multiplied by 34.97 and 0.2423 multiplied by 36.97. Then we just add these values together. So this first equation gives us 26.4968. The second equation gives us 8.9578. We add them together to get 35.4546. But we have to be aware of sig figs in units. So this answer comes out to 4 sig figs. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And the unit is either atomic mass unit or daltons. Alright, that's it for this video. See you in the next.